Does this model make sense? Let me get it where we can see the equations at the top. This is a different one. This is like an alternative product kind of thing. I mean, it's your own product, so you don't think of it as competing in that sense, but kind of an alternative product kind of thing. Peak and off-peak usage. Okay? So peak and off-peak demand that we're balancing out against each other. Okay, that's different. And you would have to be given all of these. You would never generate any of this stuff yourself. You'd have to be given these functions. And that's a little different from this one, where we were looking at the regular old, I say that because we did it so many times before this, but profit maximizing price model, where we added a complementary product into it. Okay. And then looked at how we had no need to really actually force it in those instances. Well, we never have to force it to sell it higher than the cost, because if there is only one product, it's not going to do it anyway. If there are other products, the only reason it would do it would be because you might make more money if you did. So no reason to ever force it to do that. Okay, we good with the nonlinear models? Then what we're shifting over to, I am closing this Excel because Palisade can be temperamental on some things that sometimes, and the less sheets that are open, the better. Okay, so I'm closing this one, and I have opened though the simple regression. But before I come back to this simple regression worksheet, I am going to look at the simple regression PowerPoint so we know what we're doing. All right, so here's what we're going to be doing next, and it will involve us using stat tools. We're going to be working with regression. Regression is a tool that allows you to take data that you think is related to each other, kind of like our golf club stuff where we had price and the demand at each of those price levels. That was an X and a Y. Okay, we plotted that way. And we believe that our X in some way impacts our Y. Okay, so the same thing would be true if we do a regression, or at least we'd be checking to see if it is true, if our X impacts our Y. So the idea of the regression is that you could use what you know about X to help you explain Y. You could use what you know in X to help you predict Y. But you'd have to have some data where you have pairs of X's and Y's, okay? But that X can help you explain and predict Y. Or we hope it can, and that's what we're trying to figure out if we run a regression, is if it actually can help us explain and predict Y. And so sometimes I have more time between the golf club and this example, and so we revisit the golf club. We just did it at the beginning of the class last time, so we're not actually going to revisit it because we just did it. Okay, but we are going to start on this first simple regression problem. The first simple regression problem is a video game tracking of how many times somebody played and the score that they got, okay? The assumption being that how many times you play would impact how you do on a score. I mean, I guess the assumption would be the more times you play, the better your score would be, but we're gonna see if that holds true for this data or not. And we have 60 times, this person played 60 times and 60 scores, okay? We're going to plot it, we're going to run regression on it, we're going to answer questions about it, we're going to use it for predictions, we're going to do all of that. Okay? So all with that data, and learn how to use stat tools along the way. We won't get to this problem. We will not get to the cost regression problem. It is a simple regression, but we're just going to roll it in next time with multiple regression, and it'll fit really nicely anyway, because it's sort of the beginning of those problems as well. All right, to our Excel. So here's our Excel. The number of times somebody played, the game score, that's it. 60 of them, 60 pairs of that data. All we have to have, and we can run regression. So here's the deal though. We are going to be using the Palisade tools, and so you minimize out of all of this. Okay. When you downloaded Palisade, you've got a whole bunch of stuff, Neural Tools, Precision Tree, Evolver, and all this. The two that we're going to use are Stat Tools up there and At Risk. Those are the two that we will be using. For regression, we'll use Stat Tools. When we get to simulation, we'll use At Risk. And I have to tell you real quick, there are lots of things you can do regression with. Lots of tools you can do. And to be honest with you, if all we were doing in this class was regression, then I probably wouldn't even bother with the whole Palisade, buying it, downloading it, or anything else, okay? Because there's so many other tools we could use. But when it comes to the simulation, this At Risk is fabulous. It is such a good tool for incorporating simulation into spreadsheets that we already understand, okay, that it's so worth it. So I figure if we're gonna do Palisade, we might as well use both of them then. Okay, there are, like I said, other ways we could do this, but we're gonna use stat tools for our regression, mainly because we wanna get used to the whole Palisade tool, because at-risk is great, okay? So here's what I'm gonna do. I don't even have to have Excel open. It would open it, but either way, okay, I'm gonna double click on my stat tools to begin opening it. It takes a minute to open. And it may open one or more boxes. There might be one you have to say okay and one you have to say close. Maybe it'll just open one box. Yours might open two. Okay. But what it did was, it just put this new Stat Tools ribbon, okay, Stat Tools ribbon right there onto your menu area. Okay. And just so you know, you can't leave it open, okay? Every time you close it, you have to reopen it. Yeah, you have to go back and reopen Stat Tools every single time. There's not a way to set this up where it would just open, I don't think. Well, there might be. Oh well, doesn't matter. We'll just open it up every time. So here's Stat Tools. There's some quirky little things just to get used to in using Stat Tools. And there's that side of it where you're going to have to just learn how to use the tool, and you're going to have to learn what to do with the settings in order to produce the output. And there's the other side of it. You now have to be able to look at regression output and understand and interpret it. Okay, but to get that output, you have to be able to use the tool. So we're gonna work our way through this slowly. You know, some of it's just tedious little stuff, some of it's just double checking, making sure you have everything set right. Okay, so the very first thing you understand about Stat Tools is Stat Tools doesn't let you do anything with a data set if you have not defined that data set or named that data set. Okay, so this data set right here, I'm going to put my active cells somewhere inside of it. Doesn't matter, anywhere. Then I will use where it says right here, Data Set Manager. When I click on it, it's going to recognize that I have a data set here going from A3 all the way down to B63. Okay, it picks up on that. So when it says, do you want to add this as a range? Say yes. Here's what I want you to do. I said this in my first class, and then I saw a bunch of people didn't do it when they came up to me and asked questions. Your life will be simpler if when you name these data sets, you don't call them data set 1, 2, 3, okay? It'll be way easier if you make a logical name to go with it. And understand that for every problem, just about, that you do in regression, we're gonna both do regression and we're gonna do prediction. And so my naming convention on something like this one would be to describe whatever the data set is, like video. Okay, I don't want to, get really long names or anything, but video. Okay, and then I would also call it regression. That's because the video is going to have more than one thing. So don't just call it video, or you're not going to know which one it is, which data set it is. Okay, so I'm going to refer to this as video regression because it is this data set. It's the data set I'm performing, the video data set that I'm performing the regression on. Okay, so I call it video regression. That's all I need to do. Give it a logical name and click OK. Now, all the versions don't always do this formatting thing. Some of them do, some of them don't. Anyway, so if yours didn't just reformat for you, no big deal. If it did, great. Okay. Nonetheless, you have now defined this data set. Okay. After I've defined a data set, one of the things that I do to decide, do I really think that the number of times that somebody played this game really has an impact on their score? One of the things you do to figure that out is a scatter plot. That's a very normal first thing that a statistician does when they're looking at data. Okay, so I'm going to go in here where it says summary graphs, and I'm going to choose a scatter plot. Okay. Every little piece of this you look at before you click OK. Okay, because you want to just be really careful up front. Simple XY chart comes up when you choose scatter chart. I know we only have one data set right now, but when you get into other problems that you're doing, or later, even when we're working on it next Tuesday, when you're working on it in the exam, you're going to have more than one data set defined after first, second, third thing you do. So always check here to make sure this is on the right data set, okay? Granted, we only have one right now, so I know it's on the right one, but I'm still gonna check that it's on video regression. Okay, then I'm going to tell Excel Which of these is X and which of these is Y? Okay, which one's X? The number of times playing, and Y is the game score, because it's the X that we think impacts the Y. Okay, so that's the X and the Y. All right, don't do anything else still. This is probably by default on. I would leave it on. If it's not, I'd probably turn it on. But there's one more thing that you have to do. And we all have to do this, and we all have to do this the day of the test, if it isn't already like this. Okay, and that's go to this little box right here where there's this little double check mark. These are settings. And there's one setting that's really important to me, and that's where you place your output. Okay, so the placement on yours right now, first time you ever bring it up, probably says new workbook, right? Most of you who are doing it right now, it probably says new workbook. That's like the last thing in the world we want to have happen, is for your output to go to a new workbook, especially the day of the test. Because then your output's not in your file, okay? The file that you're going to be submitted to have graded. You know, this is not good. So one thing I am definitely going to want you to do, when you click on this, it actually gives you a drop down arrow with your choices. I want all of us to always choose after the last used column in the active sheet. We have to consistently have it in the same place so the graders can grade where your output is, and so your output doesn't get left and not in your solution file, you know. So we're all going to say after the last used column in the active sheet, and then click OK. For you, on your laptop, this should be the last time that you have to do that. But I'm just saying that when we walk in and we're at CASA, I don't know what it's going to be set on. If you don't remember, in the instructions, if it says make sure your output is on this sheet to the right, you know, then you ask us. We'll help you set it. The last thing we want to have happen is this not be in the right place. Okay, so ask us if you don't remember how to set that. All right, so once I've made sure I'm on the right data set, appropriately set my X's and Y's, and all my other settings are correct, I click OK, and I get this. And depending on what version of stat tools you have, you'll have student version, the stat trial version, depends on what you're using. I'm sure there'll be words written across your stuff, but anyway, if they're not, that's great. But this is a plot of X, number of times playing the game, Y, your score. Okay. So, one thing you'll note is the correlation here. I'll point it out now because I'm going to point it out again in a minute. But that correlation's not bad. 0.855 is a pretty good correlation. I think that it is obvious when we look at this that there is a relationship between these two. And that's a positive relationship. And that as your game number of times you play goes up, your score does too. Not perfect, but it's pretty good. It's got correlation of 0.855. That's not bad. Okay. Well, here's what regression does. I'll recreate those dots. Okay. So here's what regression does. Regression puts a line through your data, just like we added a trend line to our golf club price demand stuff. It puts a line through your data. The line that it puts through your data is what you call the line of best fit, or the least squares line. I heard those terms from statistics, maybe you remember all that? Because what it's trying to do is put a line in there that fits the best that it possibly can. So what's best fitting? Well, if it could go through every single point, that would really be the best fitting, but it can't. And so it looks at what we were referring to last time as residuals or errors. We were referring to them as errors. There are also residual amounts here. Okay, so there's some error, some residual between what really happened and what we would have predicted would have happened. What really happened and what we would predict, what really happened and what we would predict. Okay? So regression, whatever regression tool you're using, its goal is to minimize those squared errors. That's why they call it the least squares line. Okay? Minimize those squared errors. In other words, fit this data as best as you possibly can. This is linear regression. Okay, it will always be fitting a straight line. It's linear regression, and linear is y equals, a plus b x. Okay, that is going to be the equation of this line. Then describes this relationship between these two, and then also can be used for predicting. Because if you know the slope and the intercept, you can plug in an x, number